Sweta madam, is it audible to you?
Yes, sir. Ah.
Hello, Sweta madam.
Okay, sir. Okay.
Dear participants, good afternoon to one and all. Just wait for 2 minutes. Our guest is coming. I will start in 2 minutes, please. Dear participants, please wait for 5 minutes. Our speaker is facing some problem to join the meeting. Just wait for 5 minutes. Gangaram sir. Hello, Gangaram sir.
కనబడుతున్నా సార్?
Yes sir, yes sir.
Okay.
Is my voice audible to you, sir?
Yes sir, it is audible sir.
Okay, okay. Thank you, sir. We will share the PPT, sir. No
Okay,
problem.
okay.
Just 1 minute, sir. Sweta madam.
Sir.
Don't share, but PPT. Sweta madam, is it audible to you?
Yes, sir. Yes, sir. Okay.
Good afternoon to one and all. Sorry for the delay. A warm welcome to the last day session of this online 1 week faculty development program on advancements in construction materials and practices. Now I take a privilege to welcome today's speaker, respected Dr. Sidam Gangaram sir. He is going to explain an innovative materials and emerging technology in building construction. Before start the session, I request Mrs. G. Sweta Madam, Assistant Professor Civil Engineering, to introduce the speaker. All the very best to all of you and happy learning.
Thank you, sir. Good afternoon, one and all. It's a great pleasure for me to introduce today's speaker, Dr. S. Gangaram sir. He is presently working as Executive Engineer in BSNL Civil Division 2, Hyderabad, Telangana State. He did his PhD in Civil Engineering from JNU Hyderabad. Prior to this, he completed his ME in Structural Engineering and BTech in Civil Engineering, and also did his MBA from Andhra University. He has 30 years of vast experience at various levels as executive engineer, junior engineer in BSNL, and also worked in Singareni Collieries for 2 years in estimation, valuation, manual, e-tendering, planning, preparation of bills, designing and execution of civil works, and also administration, arbitration and court cases. He has published 10 research papers in various Scopus journals and conferences. Thank you, sir. Welcome you, sir.
Thank you, madam.
Yes,
Shall I
sir.
start? Madam?
Yeah, sir. Please start the session, sir.
Good afternoon, all of you.
Sir, your voice is not clear.
Good afternoon, all of you, sir.
Sir, your voice is not clear, sir.
Good afternoon.
Clear?
Hello. Good afternoon, sir. Hello.
Okay, sir. Please go ahead, sir. Sweta madam, please share your PPT.
Okay, sir.
Is it audible, sir? Good afternoon, sir. Hello. Good afternoon, sir.
Hello, sir. It's okay, sir. It's okay. Please go ahead, sir.
Okay, sir. Good afternoon. Today I am going to present as part of faculty development program organized by Gokaraju Rangaraju Institute of Technology, Hyderabad. So today's topic is use of innovative materials and emerging technology in building construction. So outline of my presentation is I have divided into 3 parts of my presentation. First, part 1 is special concretes. Part 2 is emerging technology in building construction. Part 3 is substitution of secondary cementitious materials with recycled aggregate concrete. Next, about special concretes are new building materials. Part 1. So from here, aggregate from other natural sources, high strength concrete, self-compacting concrete, self-compacting concrete, mass concrete, cellular lightweight concrete, technical textiles, geotextiles, and fiberglass. Finally, I am going to focus on recycled aggregate concrete as I have done research on this topic. Next, introduction. There is a scarcity of aggregates from natural sources. There is a need to supplement the use of aggregates from natural sources with use of aggregates from other sources. Revised, especially revised IS 383 course for coarse and fine aggregate concrete also covers provisions regarding quality of requirements and extent of utilization of iron slag, steel slag, copper slag, bottom ash from thermal power plants, especially recycle aggregate concrete and recycle aggregates sourced from construction and demolition waste. Next, iron and steel slag aggregates. The iron and steel slag is obtained as a byproduct while producing iron blast furnace or basic oxygen furnaces in integrated iron and steel plants. Lime in the flux chemically combines with aluminates and silicates of iron ore and coke ash to form a non-metallic product called iron or blast furnace slag. The molten slag at a temperature of approximately 1500 to 1700 is taken out of the furnace and cooled to form the types of slag products as given below. So number one, air-cooled iron slag aggregates, and next is granulated iron slag aggregates. About steel slag aggregate. Steel slag aggregate is a byproduct of steel making operations in integrated iron and steel plants. Calcined lime used as a flux combines with silicates, aluminate, magnesium and manganese oxide ferrites to form steel furnace slag. Slag is poured is a cooling yard from the furnace about 1400 to 1700 degrees Celsius and cooled by air and water. It contains about 10 to 20% metallic iron by mass to be recovered by the magnetic separation. This is metal-free slag is then crushed and screened to different sizes for use as we required. Air-cooled blast furnace slag has a high level of porosity compared to naturally derived aggregates, which contributes to high absorption capacities. During the construction, the moisture condition of the aggregate will impact workability and early age shrinkage related to cracking and durability. If the aggregate is not kept sufficiently moist prior to the batching of the concrete. Next, copper slag as a aggregates. Copper slag is produced as a byproduct from copper smelter in the process of smelting. Iron present in the copper concentrate combines chemically at 1200 degrees Celsius with silica present in the flux materials such as river sand or silica and quartz fines to form iron silicate, which is the copper slag. The copper slag thus generated is quenched with water to produce granulated copper slag. Also, copper slag is a blackish granular material similar to medium to coarse sand having size ranging from 100 micrometers to 4.75 millimeters. This aggregate has potential for use as an aggregate as per the IS 383 codal provisions. Here, volumetric expansion ratio, it should not exceed 2% when tested as per the IS 383. Next, soundness due to free lime. If the number of particles containing free lime exceeds 1 in 20, then weathering of the slag shall be continued till the further testing shows that the level has fallen below 1 in 20. Next, additional requirements. Next slide, please. Additional requirements. Okay. So, for using this slags, we require some additional requirements as per code. REA can be used as coarse aggregate and RCA can be used as a coarse and fine aggregate in accordance with the IS 383. Manufactured against shall meet all the additional requirement as given in the table below. So these are the additional requirement for using slags. Next, extent of utilization. Here, two fine and coarse aggregates are there. In coarse aggregate, iron slag, steel slag, recycle concrete aggregate, next to recycle aggregate. These are the coarse aggregate. Here, coarse in plain concrete, 50% allowed, and this is the and reinforcement concrete 25%. For lean concrete, we can use up to 100% iron slag. Whereas recycle aggregate is there in coarse aggregate. So for plain concrete, up 25%, and for RCC, about up to 25% grade, 20% only. For lean concrete, up to M50, M15 grade, 100%. Similarly, for fine aggregate, iron slag, the percentage of used for plain concrete is 50%. And similarly for RCC, 25%, for lean concrete, 100%. So limits of deleterious materials. So as per my experience, directly we take the available sand in the market, and we without testing we use those material in the field. But here it is very important to know limits of the deleterious materials in the manufactured aggregate as per the total mass of the finer coarse aggregate as per the IS 383 for use in plain and RCC and lean concrete. So here for coarse aggregate up to 8% is there. You can total it generally. This is as per CPW manual is there 8% deleterious percentage for coarse aggregate. We can add here. So next about high strength concrete. So you are all know very well about high strength concrete, but I want to throw some light on this high strength concrete also. High strength concrete is the concrete of compressed strength 65 MPa or above. For high strength concrete mixes, especially selected cementitious material and chemical admixtures, that is superplasticizer, are used, and achieving lower water cementitious material ratio is also considered. And it is very essential to achieve high strength concrete. Optimum proportion shall be selected, considering the cement and other cementitious material properties, aggregate quality, aggregate gradation, paste volume, admixture type, dosage, and mixing. For any concrete, selection of material is very important. Quality of material is very important. Proper selection of type of cement is also important. Normally 53 grade is used, and fly ash, silica fume, GGBS, or metakaolin are other ingredients in high strength concrete. So here fly ash is abundantly available. Silica fume is very costly. So it is only this is silica fume used for only specialized structures. GGBS is there. If you substitute GGBS with cement, it is the concrete will have any structure of the RCC or plain concrete structure are very durable. Like that, among all, GGBS is the best supply the cementitious material among other material for high strength concrete. In high strength concrete, aggregates greatly influence the strength and other properties of concrete. Coarse aggregate must be strong, sound, clean, free of fissures or weak planes and surface coating, and shall be as per IS 383. Crushed stone aggregates with impact or crushing value not less than 22% and combined flakiness and elongation index not more than 30% are suitable for high strength concrete. Maximum size of the aggregate generally is restricted to 20 mm. However, for grades more than M80, aggregates of maximum size 10 mm to 12.5 mm is preferred. Why? Because for more than M80 grade, these are the only pumpable concretes, and fine aggregate of coarse aggregate is preferred zone 1 or zone 2 due to availability of high fine contents from the cementitious materials. Next, the typical dosage of superplasticizer is in the range of 0.5 to 1.5%, and water reduction of 15 to 30% and can be more achieved. The adverse effects in the slump loss, delayed setting time of concrete, and additional air entrapped shall be kept in mind while deciding type and dosage of various admixtures. Sometimes cement admixture incompatibility is experienced. Compatible combinations of cement and SP need to be selected by trials or by simple tests like Marsh cone test. Next, about self-compacting concrete. This concrete innovated in the 1988 in Japan by Professor Hajime Okamura. So this is widely used in the market. In the Hyderabad also, so many skyscrapers are using this self-compacting concrete. Especially in Manikonda, see most of the buildings are used this self-compacting concrete. Especially this Lagadapati's buildings are there, 37 floors. Those complete buildings are constructed by in those buildings SSC was used, and those SSC mixed designs vetted by the NIT Warangal. Self-compacting concrete is a highly flowable, non-segregating concrete that fills uniformly and completely every corner of formwork by its own weight. Encapsulate reinforcement without any vibration whilst maintaining homogeneity. SSC is used in both present and precast and cast and situ concrete applications. SSC is used to cast sections with highly congested reinforcement and areas and present restricted access to placement and compaction. Construction of tunnel lining sections and the casting of hybrid concrete and steel tubular columns. SSC contains more fines, superior admixtures, and compulsorily any of mineral admixtures, that is fly ash, GGBS, silica fume, metakaolin, or rice husk. Fly ash and GGBS are widely used for self-compacting concrete. So generally, from the academic point, if you don't see this self-compacting concrete, we feel that it's a something new concrete, but it is equivalent to conventional concrete. Just we are adding super plasticizer to improve the flowability. That's all. It is 99.99% is equivalent to conventional concrete. It is just we are adding higher water reducing agents, not more than that. This is very similar to conventional concrete. If you cast cubes, but it requires for getting 90% strength. Generally, we get we test it 7 days and 28 days for cube test, but it requires additional 2-3 days extra requires. Suppose 7 days cube we want to test, additional we have to test those cubes at 10 days. Suppose we want if we required the target strength of 28 days, it requires 2-3 days extra because of use of this super plasticizer requires more setting time. So these are the properties. So M30 and above. So cementitious content is 400 to 600. Here I want to mention here cementitious content. So as per the IS 456, the cement quantity of cement is restricted to only 450. But here what we have told here, cementitious content means you can restrict 450 cement, remaining 150 GGBS you can add. So that also we have to fulfill the codal provisions. Otherwise, for M30, 400 is not advisable. It is very expensive. So when we design the mix, we have to think about the cost of the concrete also. No, so this is the simple flow test. So these are the very simple test. Here compressive strength also will get. Here about compressive strength. So for conventional concrete, we test 7 days. There is no issue. You will get 7 days strength, but whereas for this SSC, you have to test it 3 days more. So 7 days strength, you will get it 10 days. Next, this is slump flow 1, 2, 3. These are the codal provisions. So these are the codal provisions. Whatever the our tests are there, those test results has to comply with this codal provisions. This is about self-compacting concrete, passing ability, segregation. Next, mass concrete. About mass concrete is used for structures like dams, other massive structures. Roads also comes under mass concrete. For such large structures, measures need to be taken to cope up with the generation of heat from hydration of cement and attendant volume change to minimize cracking. The primary objective of proportioning for mass concrete is to establish economical mixes of proper strength, durability, permeability with adequate workability, easy placeability and least temperature after placement. If we do not maintain temperature, the cracks will appear immediately after concreting. In mass concrete structures, generally lower grade of concrete, say M15 or M20 and higher sizes of coarse aggregates are used. Additional data required for mix proportioning for mass concrete. Expected maximum placing temperature, air content range in case of air entrant concrete, test ages of strength, so on. So in the mass concrete, water reducing admixture or plasticizing admixtures are effective in mass concrete mixes and usually decrease in water content by 5 to 10% at appropriate dosages. See, dosage is only 0.5 to 1.5 as per the code 9103. So air entrant in mass concrete 150 mm MSA to and 80 mm MSA consider for useful due to marked improvement observed in durability, particularly under freezing and thawing. So this is applicable in North India only, not applicable in South India. Next, cellular weight concrete. Cellular lightweight concrete. Cellular lightweight concrete is a versatile material made up of cement, fly ash, and protein-based foam, mostly used in India for walling purpose as a non-load bearing structural element, which has lower strength than conventional concrete and is popular because of its lightweight, which reduces self-weight of the structure. It is a good substitute for ordinary clay bricks, which use high energy and precious agriculture. So here, so generally mass of the concrete is density of the concrete is 24 to 26 range, 22 to 25 range mass of the concrete, density of the concrete. But the for lightweight concrete is so 600 to 1000 is there, lightweight concrete. So there are micro lightweight concretes are there, that is 300 to 600 density of the concrete. So in cellular lightweight concrete, fly ash based cellular lightweight concrete, in cellular lightweight concrete, the density can be controlled by the introduction of gas or foam by foam generator. Fly ash can be more than 25%, ranging between 26 to 33 of solid material constitute CLC mixes, cellular lightweight concrete for different density outputs. So CLC can be produced in a density of 400 to 800 kg per cubic meter with a high insulation value and a 28 days cube crushing strength of up to 275 kg per cm square. Next slide, please. Hello, excuse me. Am I audible, sir?
Sir, yes, sir.
Okay. Because from phone, I am not able to present properly, madam.
Okay.
So not visible properly. So about cellular weight concrete, as per IS 65998, there are two types of cellular concrete for thermal insulation. Type 1, high pressure steam cured autoclaved material in the form of precast blocks. Second, materials cured under natural conditions, that is under ambient pressure and temperature. The dimensions of the type 1 and type 2 precast cellular concrete blocks are normally either 50 or 60 centimeter length, that is 25, 20, 25, 30 centimeter width, and 7.5 or 40 centimeter thickness. The grades in this concrete grades are there: A grade and B grade. Follow C grade. A grade is lightweight cellular concrete. B grade is medium weight cellular concrete, and grade C is heavyweight cellular concrete. So some requirement cellular concrete for thermal expansion. So here density is there for grade 1 up to 320, grade B 321 to 40, 400, grade C 400 to 500. The test reference is IS 5688. So next, technical textiles, geotextiles. This is some another special type of concrete. Technical textiles are textile materials produced primarily for their technical performances, functional properties rather than aesthetics or decorations. There are many types of technical textiles available nowadays. These are classified as agrotech, buildtech, clothtech, geotech, hometech, indutech, meditech, mobiletech. So like that, so many are there. So buildtech are technical textiles used in construction of buildings structures. So about architectural members are used in many permanent structures and products include hoardings, signage, cotton canvas, tarpaulins, HDP tarpaulins, awnings and canopies, scaffolding nets, floor and wall coverings. These textiles are used for to protect the material from the weathering action. So these are the codal provisions, strength requirements. So next, fiberglass. Can you change, madam, this up to fiberglass? Okay. Next, fiberglass are made of extremely fine fibers of glass formed when the thin strands of silica-based or other formulation glass is extruded into many fibers of small diameters suitable for textile processing. Glass fibers are lightweight, having low susceptibility to moisture, high electrical and thermal insulation, mechanical properties, and high impact, corrosion, and fire resistance. Glass fibers can be randomly arranged, flattened into sheet, or woven into a fabric. Textile glass fibers may be formed from molten glass directly from the furnace. Glass fibers can be derived into two major groups according to their geometry as continuous fibers used in the yarns and textiles, and discontinuous fibers used for insulation or filtration, etc. Fiberglass is a common type of fiber reinforcement plastic where glass fibers act as a reinforcement in the concrete. Fiberglass textiles are commonly used as a reinforcement material for molded and laminated plastics, while fiberglass wool made from discontinuous fibers is used for thermal insulation and acoustics. Suppose fiber reinforced plastic or glass fiber reinforced plastic are the terms normally used for manufacturing various products. Next, fiberglass reinforcement panel blocks. Next slide, madam. Fiberglass reinforced panel blocks. You can see in the 5-star hotels wherever you go, they construct fiberglasses. They are transparent, almost all. These fiberglass reinforcement panels are used in walls installed directly or solid surfaces or frame and ceilings. So glass fiber reinforcement gypsum panels are manufactured to thickness of 125 mm under controlled conditions to a depth of 12 meters, height of 3 meters. It contains cavities that may be unfilled, partially filled or fully filled with reinforced concrete as per structural requirements. The GFRG panel is manufactured in semi-automatic plant and dried at a temperature of 275 degrees Celsius. The wall panels can be cut as per dimensions and requirements of the building planned. Some of the advantages of fiberglass reinforcement panels are GFR panels provide a strong scratch resistant surface, easy to clean with regular detergents, high pressure washers, or steam. GFR panels are lightweight and easy to install. They can be installed with fasteners or frames or even with adhesives. They are waterproof, corrosion free, and have improved chemical resistance. GFR panels can be installed over any existing wall surface or substrate. They have high impact resistance. GFR panels can be manufactured according to required shape and design. So especially these are preferred. Why? Because GFR panels can replace natural materials, hence are environmentally friendly. So next. Next, madam, fiberglass. Next slide, madam. Next slide, please. Back, madam. Back. Right, madam. So glass fiber reinforces concrete panels. These panels consist of glass fibers at the rate of 3.5 to 5% by weight, silica, white cement, and admixtures. GFRC panels can be used in the facade instead of natural stone, thus qualifying as a green material. These panels are installed on a facade on hard dipped galvanized MS framework and brackets. Water repellent coating can be applied on the panels by dipping panels in the required solution to withstand atmospheric conditions. Another advantage of such panels is that they can be manufactured in any shape, including curvilinear surfaces. These panels are also weatherproof and durable, especially in the buildings in central area. For domes, they are using here, and sunshades also they are using these fiberglasses. Next, a summary. So about aggregates from other than natural sources. Recycle aggregates for which research has been done more than 70 years. Still research going on, use of recycle aggregate for structural concrete. So as per the code IS 383, it is permitted for the use of lean concrete 100% and RCC about 25%, and plain concrete I think 50%. But in the in practically in the market, the owners of the building are reluctant to use this because lack of awareness about the recycle aggregate. Regarding high strength concrete, already it is in practice. Next, self compacting concrete, already it has been used in all the world. Mass concrete, it is also widely used. Next, cellular lightweight concrete, still it is needed further research. Next, technical textiles, geotextiles, still it is needed further research. Next, for fiberglass, still it is needed further research. So finally, use of new materials has become very essential to reduce greenhouse gas emissions and reduce construction cost. So next, part 2, new and emerging technologies in building construction. So our outline of this part 2, monolithic concrete construction system using aluminum formwork. So monolithic concrete construction system using plastic aluminum formwork. expanded polystyrene core panel system, light gauge steel framed structures system. Next, industrialized 3S system using RCC precast with or without shear walls and column beams, cellular lightweight concrete or slab or semi precast solid slab, speed floor system, glass fiber reinforced gypsum panel building system, factory made fast track modular system. This is outline of presentation. It's introduction for part 2. CPWD has recommended adoption of new technologies in construction. Sorry, as these will result in the following benefits: significant reduction in air and noise pollution and construction waste, optimum usage of water, no use of timber, plywood for shuttering, form finish elements, good workmanship or quality and durable construction, increased labor productivity due to working in controlled environment, all weather site construction. So all the seasons, cost saving due to compressed completion time and rental cost reduction, better site organization, utilization of resources. CPWD has also brought out schedule of rates for all 8 new emerging technologies and has approved more new emerging technologies, latest being wide dated 23 in the year 2020, stating that as per mandate of Ministry of Housing and Urban Authority, at least one of the approved new and emerging technology, which now are 60 numbers, is to be adopted in future projects, irrespective of location and cost. See, about monolithic concrete construction system using aluminum formwork. Conventionally, we use for wooden formwork we use for in the olden days, but nowadays it is very difficult to get the wood and it is very costly, and this forest authorities also they will not give permission to take out the wood. To replace the conventional steel or plywood shuttering system with customized engineered formwork manufactured in the factory setup under controlled conditions. Custom designed modular formwork made up of aluminum, plastic composite used for this purpose, which facilitates easy handling with minimum labor and without use of any equipment. Being modular formwork system, it enables fast construction of multiple and mass modular units. Monolithic construction carried out by using aluminum formwork system allows casting of floor in a single operation. M1 is the name of Malaysian company who invented it in 1990. So this is the aluminum formwork. Directly we can pour the concrete from the upper side. That is very easy. Around 100 houses also we can cast in a one day if we plan in advance. So structural requirement of construction suitable for low to high rise structures. The monolithic RCC construction is a shear wall system. The maximum spacing between cross wall is limited to 1.5 times the floor height if supported on 2 edges and 2 times the floor height when supported on all 4 edges. The walls are designed for vertical loading and also for in plane lateral load, shear out of plane bending due to wind load or earthquake forces as per IS 875. For out of the plane loading, the plate can be assumed to be supported by floor or slab diaphragm and cross walls, and continuity can be assumed. Thickness of the wall is generally 100 mm with centrally placed reinforcement. Therefore, adequate cover is maintained and high durability is achieved. So this is very economic and so many advantages are there. Next, monolithic concrete construction using plastic aluminum formwork. To replace the conventional steel plywood shuttering, in place of traditional RC frame construction, all floors, slabs, columns, beams, walls, stairs together with door and window openings are cast in place monolithically in one operation. This is very easy and faster construction. Custom designed modular formwork made up of aluminum plastic composite used, which being lightweight, facilitate easy handling with minimum labor and without use of any equipment. Being modular formwork system, it is very much suitable for fast and mass construction and multiple modular units. So if we use this formwork, so we can plan our quantum of work. So limitations here, however, a lead time of about 3 months is required for start of the work, as the formwork are custom designed and manufactured. A prototype needs to be approved before manufacturing. Also, a number of sets of formworks required. Capital cost to initiate construction is high and may require regular flow of funds. Post-construction alterations are difficult. All the service lines are to be pre-planned in advance. Not much saving in construction in one story or such small structures. This is advisable for massive construction only. This is not recommended for one building or two buildings, G+1 or G+2 like that. Next, expanded polystyrene core panel system. Next, expanded polystyrene core panel system. Next, madam. Madam. So, expanded polystyrene core panel system is based on factory-made panels. Consist of self-extinguishing expanded polystyrene sheet corrugated with minimum density of 15 kg per cubic meter, thickness not less than 60 mm, sandwiched between two engineered sheet of welded wire fabric mesh made up of high strength galvanized wire of 2.5 mm to 3 mm dia. A 3 mm to 4 mm dia galvanized sheet truss wire is pierced completely through the polystyrene core at the opposite angle or for superior strength and welded to each of the outer layer sheet of the steel welded wire fabric mesh. The panels are finished at the site using minimum 30 mm thick shotcrete of cement and coarse sand in the ratio of 1:4 applied under pressure. The shotcrete coat encases the EPS core with centrally placed steel welded wire fabric mesh. Next, features of panel system: load carrying capacity, seismic performance, thermal behavior and energy efficiency. So here, seismic performance. The prototype houses tested for seismic loading came through unscathed. Buildings made using panels are particularly lightweight, so have a low seismic mass, but are at the same time rigid due to two sheets of reinforced plaster that interact to create an enveloping shell of the whole structure. The thermal behavior and energy efficiency, the thickness and density of the panel can be customized to deliver a specific thermal insulation requirements. Further, the EPS core extends throughout the surface, resulting in a wall with 80 mm core and finished thickness about 150 mm provides the same thermal insulation as an insulated solid masonry wall of about 400 mm with obvious advantages in terms of additional space. These are the advantages: fire resistance, good acoustic properties, rapid installation and cost effectiveness, lightness, ease of transport and handling, versatility and a complete range of building elements, and blast resistance and cyclone resistance. Wide choice of finishes. Requirements for setting up a plant. Next, light gauge steel framed structure system. So light gauge steel framed structures is based on factory made galvanized light gauge steel components. LGSF is typically suitable for low rise, medium rise structures, 1 to 3 story high residential and commercial buildings. The system is produced by cold forming method and assembled as a panels at a site, forming structural steel framework or a building or a varying sizes of the wall floors. Next advantages. Next, madam, advantages. Here advantages. So lightweight gauged steel LGSF is based on established system of light gauge steel structures and designed as per the Indian standards. World provisions for loading. The advantages of the system are high precision, fully integrated computerized system with CNC machine, provides very high degree of accuracy up to 1 mm, good structural behavior, high strength to weight ratio due to low weight, significant reduction in design earthquake forces, chances of progressive collapse are marginal due to high ductile and load carrying nature of closely spaced studs joints. Speed in construction speed is very high. A typical 4-story building can be constructed within 1 month. Saving in foundation, structures being light does not require heavy foundation. Mobility, structural elements can be transported to any place including hilly and remote areas easily, and structure can be erected within short time, and this is very environment friendly. Steel used can be recycled when required. Structure can be shifted from one location to another without wastage of materials. So this is the system. The industrialized total prefab construction technology based on factory made and mass manufactured structural prefab components conforming to relevant IS code. This technology is durable, fire and impact resistance, fast, economy of minimum 5,000 dwelling units. The major precast elements are RCC hollow columns with notches, RCC solid beams, TL square shape staircases, and AAC precast slab, AAC precast blocks. Next, in this system, precast dense concrete hollow column shells of appropriate size are used in combination with the precast dense concrete. Rectangular T or L shape beams with lightweight reinforced autoclaved cellular concrete are precast RC slabs for floor and roofs. Hollow columns are grouted with appropriate grade of in situ concrete. All other components and jointing of various structures are accomplished through on-site centering along with the sourced embedded reinforcement of appropriate size length to ensure monolithic continuous resistance, ductile and durable behavior. So some essential requirements. Next, limitations. Next, speed floor system. In this system, speed floor is a composite floor system using both steel and concrete. It is suitable for low rise to high rise structures. It is a durable, speedy and economical suspended concrete flooring system using a roll formed steel joist as an integral part of the final concrete and steel composite floor. Is suitable for use in all types of constructions. It is essentially a hybrid concrete or steel T-beam in one direction and integrated continuous one-way slab in other direction. In speed floor composite floor system, floor joists are designed and custom manufactured from pre-galvanized high tensile steel in one pass roll former, where it is roll formed, punched, pressed, and slotted in a fully computerized machine to suit particular job conditions. The joist depth and concrete thickness are varied depending on the span, imposed loads, and other functional considerations. Is the time, madam? Hello? Hello? It's madam? Hello?
Sir,
Madam, what is my time, madam? How much time
Sir,
left?
no problem, sir. 10 more minutes, continue. 10 more minutes.
10 more, sir. I will.
10 or 15 minutes, no problem, sir. You take your
Okay,
own
sir.
time, no problem.
So I will skip some skits, sir.
No problem, sir. Continue, sir. Take your own time. Otherwise.
1 minute. Because from I am presenting from my mobile, sir, it is very difficult. Sorry.
Okay,
sir,
yeah,
it is not
understood,
present.
sir. Understood.
It is not
Please,
looking
please
proper.
continue, sir. Please continue.
Okay, okay, sir. So, madam, please come up to this part 3, madam. Part 3.
okay, sir. Okay, sir.
Part 3, madam. Part 3, madam. Part 3. Use of secondary cementitious materials and
Topic,
substitution of
Topic.
part 3, madam.
Sir, slide number is there? Any slide number? Part 3? Can you?
76, sir. Slide number.
Okay, sir.
Okay.
Yes,
So,
sir. Okay.
as part of my presentation in this faculty development program, this is part 3, use of secondary cementitious materials and substitution of natural aggregates with the recycled aggregate. So here, secondary cementitious materials are GGBS, silica fume, metakaolin, flash, and microsilica, and so many are there. But here I am focusing on substitution of GGBS and recycled aggregate. So, strength and durability of recycled aggregate by substituting secondary cementitious material and conventional aggregate with recycled aggregates. Due to continuous bombarding during World War II, the cities have become heaps of demolition waste. After World War II, an idea was conceived to recycle and utilize the demolished waste as a recycled aggregate. Since then, continuously, research has been going on to utilize the C&D waste by recycling. The construction industry is reluctant to use recycled aggregate due to lack of awareness about its quality. But so far, some of the countries like USA, Japan, Korea, and European Union are adopted standard procedures for use of recycled aggregates. So about construction and demolition waste. Construction industry consumes natural resources massively and also produces enormous construction and demolition waste. Concrete rubble is the major problem portion of about 40% in C&T waste, which poses a disposal problem. The natural coarse aggregates are scarce and depleting at a faster rate due to increased construction activities. The problem of C&D waste can be resolved by using concrete rubble as a recycled aggregate in the concrete. Effect of processing techniques. on recycled aggregate. There are many processing techniques which have severe impact for production of recycled aggregate. Example, two-stage mixing method, washing with acids, preheating, treatment, etc. Practically difficult to adapt these techniques for production of RA. In general practice, what happens, always we recommend to use this recycled aggregate, whatever the material, it should be friendly to the common man. But whatever the research going on, it is not friendly. Suppose here for using two-stage mixing method is there. It is method was this Singapore University is there. They have introduced the two-stage mixing method, but in practice it is very difficult. Nobody will use this idea, our research idea, or research. Nobody will take our ideas. Why? Because in the practice they want to. In shorter time they have to construct the multi-story buildings. So two-stage mixing method, it is difficult to implement in the field. So whatever the research is research we are doing, it should be understood by the common man. So here in the present research work, in my research work, 100% natural aggregates I have replaced with the recycled aggregate for development of M22 M40 grades of concrete. Also, I have used 15% cement replaced with the GGBS. So, in my research work, the following steps were conducted. Tests were conducted and evaluated: mix design, slump test, compressive strength test, next splitting tensile strength, next flexural strength, modulus of elasticity, water permeability test, acid, sulfate, and chloride attack assessment of test results for 1 year. So need of the new or sustainable materials to conserve natural resources, to resolve the environmental issues, to reduce the construction cost, to save the landfill space. So this image of the fine aggregate, natural aggregates, recycled aggregate, and GGBS. Everybody knows this. So these are the physical and chemical properties of OPC. Next, physical and chemical properties of GGBS. This is also simple. Next, some images of testing of materials. Next, method is for extracting recycled aggregates. So previously we have studied about two-stage mixing, but here there is no stage, only single stage in my research. Just a collection of C&D waste from the any building demolished in the Hyderabad, whatever the city. It is if it is nearer to our where is the proposed site is there, we have to collect those C&D waste. We have to separate construction and demolition waste, and we have to make them into 10 centimeter size. And we have to wash, means we need not to wash, just we have to pour the water to remove the dust particles from the C&D waste. Next, we have to, after pouring water on the aggregates, we have to leave for minimum 7 days because it absorbs the water due to attached mortar. Next, testing of aggregates in accordance with the relevant IS codes. Next, recycle aggregate are ready to use. Generally, it is similar to our conventional aggregates, natural aggregates. So from this machine, it is available in Usmania University. Please, madam, show this crushing machine. This is available in the Usmania University. So I have extracted these recycle aggregate from this machine. Even I have during my research work, I have extracted more than what I required. Whatever the material available recycle aggregate, I have given to MTech and BTech students of Gokaraj Rangaraj students for their experiments. So this is 2011. But can I know how many these plants are there? Can I know? Anybody can tell? Is there any plants are there in Hyderabad? From the audience, please. Participants. In the 2010, there was no single recycling plant, but now in Hyderabad, 4 recycling plants are available. Just if we make a one phone call, immediately they will come and collect the C&D waste. So this is a detailed experiment program, finalization of mixed design and to obtain mechanical characteristics. Next, durability studies on recycled aggregate concrete. Next, validation of theoretical studies by conducting experimental work. In this presentation, I am not explaining about validation of theoretical studies by conducting experimental work because it requires more time. So this is my trial mixes. So trial mixes, number of cube cylinders, all 300 I have casted. And for final design, 1665 this cube cylinders prisms I have casted, and number of RCC beams 60 numbers, and total is 1995, and total number of beams are 60, and grand total of samples are 2055. Next, concrete mixed design methodology. In the present my investigation, I have taken M20 to M40 grade of concrete using 100% recycled aggregate, including replacement of 0%, 10%, and 15% cement with GGBS are selected and are designed as per IS 10260 only. So what I want to say, I have used recycled aggregate which are easily available, just collected and from Usmaro city, I got those recycled aggregates, and I have done my experiments. So this design methodology, there is no specific design method required for design of mixed design of M20 M40 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 grade. Only I have used this IS 10262. Next, these are the final design mix quantities. Time is there, sir? 5 minutes, sir?
Yes, sir. Yes, sir. Please go ahead.
Okay, sir.
5 minutes you take, sir. No problem.
Okay, sir. So these are the quantities in kg per cubic meter for selected grades of concrete. Final these are the mixed designations. So these are the images of some experiments. This is my experimental work. Details of splitting and tensile strength test. Next, details of flexural strength test. So here I want to tell you something here in this figure. All mixes achieved the target flow of slump at 15% GGBS. So what are the slump values of plain concrete and mass concrete and RCC ordinary? Participant, can you tell? I am questioning you. What are the slump value for plain concrete? Plain concrete slump value. We continuously do slump test, but what are the specific value? Mass concrete or RCC for ordinary buildings. Next here, comparison of test results of compressive strength. Comparison of test results of compressive strength. So I have compared my test results of compressive strength. So participants, I am asking one question: what is the percentage of compressive strength at 7 days? Why do you conduct at 7 days? Can anybody answer this? Srinivas sir.
Sir, to test the early strength, sir, we are going to test the 3rd day and 7th day test. Whether the early strengths are achieved or not, we are going to assess that one.
Sir, what sir? 3rd day, 7 days.
3rd day and 7th day test we are doing for assessing the early strengths, sir.
So for the
Generally, it is habituated to test on the 28th day, but whether it is achieving early strengths or not, that's why we are going to test on 3rd and 7th day.
But practically, is it correct, sir? Can you correlate this industry to
Yes, yes,
construction
100%, sir, 100%. Wherever it is, for example, for road repair works are there, sir, it is required to get early strengths. So it is mandated to get the strength on 7th day also, sir. That's
So
why the feature of high strength concrete is high performance concrete is one that it should get the early strengths also.
So generally, sir, I don't recommend 3 days strength. I recommend 7 days strength, 28 days only. Why? Because for faster construction, we test at 7 days. So we cast at 6 cubes, sir, practically at the construction sites. First 7 days, we will send 3 cubes to the lab. Okay, sir.
So at site, whatever you are doing, sir, but theoretically, from the laboratory point of view, all 3 days, 7 days mandatory, sir.
So no, sir. 3 days is not mandatory. 7 and 28 days, sir, generally. So here, just I want to correlate, sir. 7 days and 28 days we cast, sir, at the construction site.
Okay.
So 7 days cubes we will send to the lab, sir.
Okay.
Okay, sir. Suppose 1,000 crores project is there. 7 days strength we will send to the lab. So after getting those 7 days result, we will proceed the work, sir.
Okay.
Okay, sir. Suppose if 7 days strength is failed, then we will go for 28 days.
Yeah, if it is normal concrete, 70% of 28 days, 28 days strength should be achieved at 7 days. Sir, you are, please unmute, sir. Please unmute yourself.
Okay, this is a sir. So
okay.
In the government, sir, in the government organization, what happens, sir? So suppose if contractor fails to at 28 days work is, if we found work is substandard, what will he has to cast again, sir, at his risk and cost.
Okay, sir.
That is important here, sir.
Okay, sir. Okay, sir. Please
sir,
go ahead. Sir.
Now lab point, it is your right, sir.
Yes, sir. Okay.
Okay. Here, sir, comparison of test results of splitting tensile strength are here. Okay, sir.
Okay. Please go ahead.
Okay, sir. Here also I want to question you, sir. Can you see my this PPT, sir?
Yes, sir. It is visible.
Why the permissible tensile strength has been conducted at 7 days, sir? My question is, sir, I am showing result to you. Is it correct, sir? 7 days.
Yeah, tensile strength should be within the limits, sir. Otherwise, cracks will be developed, no?
Yes, you are right, sir. But what happens, sir? We are mistaking here. We should not conduct 7 days strength, splitting tensile strength, sir. Okay, sir.
But at lab conditions, these are all required, sir. From the research point of view and at lab conditions.
No, sir. It is not possible, sir. Sir, see, it is not possible. We will not get any result at 7 days, sir. This is for your kind information.
Okay, sir. Okay, thank you.
After 28 days only.
Please unmute, sir. Unmute yourself. Please unmute yourself. Sir, please unmute yourself.
Hello, sir.
Now it is okay, sir. Please continue.
Okay, sir. Here, so we have test conducted on modulus of elasticity, sir. Okay, sir.
Sir, 5 more minutes, sir. Only 5 more minutes. Please complete your session, sir.
Okay, sir. Only 5 minutes, sir.
Yes, sir. Yes, sir.
Regarding durability, I want to speak, sir.
Discussing question answers.
Okay, sir. No, sir. This is interactive session, sir. So at last, I cannot come back this slide, sir. That is
okay, sir.
So few questions I will ask, sir. At the end, you can ask.
Okay.
To study the effect of aggressive chemical environment in of acid attack, compressive strength loss of
next slide, madam. We have to go to next slide, I think. Where is that?
Durability studies.
Durability studies.
Sir. Sir, kindly interact, sir, because one way it will become one way, sir. See,
no shortage of time, sir. Already it is late. Shortage of time. That is the problem.
Okay, sir. Okay, shortage. Okay, sir. I will add my.
Continue, sir. Please continue.
No, so many slides are there, sir. It requires more time, sir. Okay, sir. I will conclude my presentation here. So next time I will take more time, sir.
Okay, sir. Okay.
Based on the experimental investigation, the following conclusions are that compressive strength, splitting tensile strength, flexural strength are on par with the values recommended by IS code. Modulus of elasticity is about 60 to 10% less than IS 456 provisions. The stress strain behavior of RCC recycled aggregate concrete is similar to that of conventional concrete. Next, load deflection behavior uncracked and cracked exhibits similar pattern as that of the conventional concrete. 15% cement replacement with GGBS recycled concrete specimens are better in terms of resistance to 1% HCl, 0.41 MgS for 3% HCl. Sir, here I want to explain you, sir. I have exposed 1% HCl, sir. Can you question
sir,
me, sir? Why?
Please explain, sir. Please explain.
Sir, generally, sir, we know very well, sir. As our structures are not resistant to acid. Okay, sir. Point. Even though I have done, why? Because
yes, sir.
Our structures are exposed to the weather, sir. Sometimes acid rain will come, sir. In that acid rain, 1% HCl maybe acid in acid rains with 1% HCl presence may be there, sir. This is okay, sir. And this is 0.41 magnesium sulfate. I have considered, sir, here.
Okay,
so these are maximums are actually we take in general what happens 5%, 10% we do. Not like that. So we should not take like that. 0.41% is maximum in concrete. Why should take 1%, sir? It should be less than 1%. So need not to test for 1% MgS4. And here two are there, sir. In MgS4. Pre-mix or post-mixing is correct, sir. MgS4. It's a academic debate, sir.
Sir,
see,
tell me.
Post-mixing or pre-mixing?
Which one,
generally,
sir?
Everybody is exposing, sir. NaCl and MgS4, everybody is testing. So pre-mixing is advisable, sir. Okay.
What is the difference, sir? What is the difference between pre and post mixing?
Post mixing, what you will get, sir? See, if you mix this MgS4, it will bulge, sir. It will change its volume. So it should be present in the concrete itself, sir. Okay, sir.
Okay, sir. Please conclude, sir. Already it is 3:45.
Okay, sir.
In the next session, we will take one more session. So in that you can cover all these points, sir.
Sir, this is my recommendation to faculty members, sir. As per my past experience in the field of industry and academics, following recommendations, suggestions are made to the faculty members and the management. BTech or MTech projects may be simple and may be fulfill the needs of the industry. And monthly lecture or seminar or internship may be arranged to the BTech students from first year of the BTech itself. For BTech or MTech projects, external guides may be attached from the industry or for better understanding of the theoretical knowledge to the field, sir. So one chapter on cost benefit analysis may be added in the BTech or MTech project. So this is what I observed, sir. Because this is the faculty development program, this is my suggestion, sir. So if kindly add one chapter for cost benefit analysis. So finally, I would like to thank Dr. Vempada Srinivas Reddy, who is my mentor and friend, Dr. T. Srinivas, my friend, Dr. Lavanya Madam, HOD, GRRIT, and all the faculty members of Civil Engineering Department, GRRIT, all the participants of the faculty development program, and finally, from the bottom of my heart, finally, I would like to thank management of the Gokaraju Rangaraju Institute of Technology for giving me the opportunity to become the part of this PDF. Thank you, one and all. Jai Hind.
Dear participants, please unmute yourself and ask the questions.
Good afternoon, sir. This is Hemlata from GRIT.
Okay, madam.
Sir, I have a small question like this. Whatever the recycle aggregates are having a higher permeability than natural aggregates. So how it can be avoided and what are the changes will be done in the mixed design processor?
So very good question, Mesa. I am looking forward for this question. I am ready to answer it. Because
Yes,
of attached motor, madam.
sir?
So see, because of
Yes, yes.
attached motor.
Yeah.
Because attached motor, it absorbs more water. To reduce that attached motor, we have to add super plasticizer. Number one. Number two, GGBS or any other cementitious material. That is enough to improve the interfacial transition zone of the concrete. So
Which
use
method?
of super plaster is very much essential, madam. Without SP, we cannot achieve the target strength of recycle aggregate. 100%.
Yes, sir. Which method is generally preferable, sir, for mixed design? Any other than IS code?
No, for which, madam?
Or trial
Up to
and
M40
errors,
I have
yeah.
done, madam. Madam, up to M40 now I have done, madam. See, madam.
So which method you have preferred for the mixed design, IS code or any other methods are there?
ISO 10262 enough, madam, for M40.
Enough, okay.
Need not any other method, sir. Note number is there, ACI, so many methods are there. Very simple method, madam. Simple method. Even that mixed design can do BTech first year student, madam. Very simple method, mixed design. M40.
Okay, sir.
But whereas M50, M60 are there, madam, it is not possible. But it is possible for further we have to make research,
There are
madam.
packing density methods and all. Have you done with that or anything?
Yes, madam. Yes, I have done, madam.
Okay.
All the experiment I have done, madam. 2055 samples I have casted, madam. 3 years, madam.
Okay, sir. Thank you so much.
Okay, madam. Any questions? Kindly ask me.
Thank you so much.
I am
No
ready
more
to
questions,
listen
please.
questions.
Any questions? Kindly ask.
If I don't answer, I will write and
I am ready to listen to questions. If I don't answer, I will write and I will reply guarantee.
Definitely I will.
Yes, I'm Hussein.
Definitely I will.
I'm Hussein. I'm professor here.
Welcome, sir. Good evening,
So
sir.
I think you have done many samples.
Welcome, sir. Good evening, sir.
Hello.
Yes, sir. I am
You
listening.
have done many samples. I think you can keep in.
Yes, sir.
You can keep all those samples in machine learning lab. Okay.
Okay, sir.
So you will be contributing that and machine learning algorithms.
Okay,
so it will be useful to us because I did the same thing using
Sure, sir.
machine learning. This thing, the data
Sure.
I have taken.
Okay.
Now my question is.
Okay.
So I'm teaching pre-stressed concrete.
Pre-stress concrete. Okay.
So the high strength concrete is needed. Okay.
Yes, sir.
Pre-stressed concrete. So shall we use this recycle aggregate in PSC?
So PSC is not recommended as per IS
Hello?
code, sir. As per IS code.
PSC is not recommended as per IS
Yes,
code,
sir.
sir.
You
As
cannot
per
use,
IS
sir.
code.
Yes.
Yes.
It is very clear, sir.
You cannot use.
And another thing is you are using recycle
It's very
aggregate.
clear, sir.
Yes. Recycle aggregate, you are using percentage of cement, you are telling. Is it by weight or by volume?
What, sir?
5%, 10% replacement you are telling, no?
By weight, sir.
CGBS.
By weight, sir.
Is it
Not
by
by
weight?
weight, sir.
By weight only?
By
Yes,
weight,
sir.
sir.
Exactly. By weight.
Not volume.
Because as per the IS code, the cement content is restricted up to 450 kg, sir.
The cement content
Not cubic meter.
restricted up to 450
It is in kg, sir. 450 kg
Not cubic
restricted.
meter.
So that's why we have to calculated based on the weight only. By weight only.
So that's why we have to calculate based on the weight only, by weight only.
Okay. Right.
Any questions, please?
Any more questions, please? Dear participants, please unmute yourself and ask the questions.
Seems there is no question, sir.
Yeah, looking like that only, sir. Okay. Seems to be no more questions, sir.
Yes, sir.
Sir, thank you very much, sir. In spite of your busy schedule, you have spent your valuable time and shared your experiences and explained very well about the different types of aggregates, high strength concrete, self-compacting concrete, mass concrete, new technologies in construction. Thank you very much, sir.
Thank you, sir.
And now, being a convener of this FDP, let me tell the conclusion remarks. Madam, is it audible to you? Sweta, madam, is it clear?
Yes, sir.
Okay. A total 55 faculty have registered for this FTP from various engineering colleges across the state, like CVR College of Engineering, Mathusri Engineering College, VJIT, Geetanjali Engineering College, Mallareddy Engineering College, Aeronautical Engineering College, and KG Reddy College of Engineering and Technology. And also 2 faculty have registered from Girijananda Chaudhary University, Assam. But 42 faculties have attended regularly for whole week. This FDP covered the topics on performance and durability of cement concretes, importance of civil engineering in electrical power transmission, role of digitalization and artificial intelligence in construction industry, significance of green building design, and innovative materials and emerging technologies in building construction. Dear participants, I hope that everybody of you must have enjoyed this FDP. I congratulate all the participants who have attended this FDP, and I'm sure that all the participants would have benefited from all the sessions conducted during this FDP. Now it's my honor to propose vote of thanks. First of all, I'm thankful to the management of GRIT for providing us an opportunity to conduct this 1-week faculty development program. And I'm also thankful to the Honorable Director of GRIT, Dr. Jandyala and Murthy sir, for continuous support and encouragement to successfully complete this faculty development program. I'm also thankful to respected the principal of GRIT, Dr. J. Praveen sir, for his guidance in conducting this FDP. I'm also thankful to respected senior AO, GRIT, Dr. KVS Raju sir, for his continuous support. And I'm also thankful to our beloved HOD of Civil Engineering, GRIT, Dr. C. Lavanya madam, for the support she has given throughout the FDP. And I thank to all the speakers who have presented during this FDP. Without their support, this FDP would have not completed successfully. And I'm also thankful to the advisory and organizing committee members, especially Dr. V. Srinivas Reddy sir, SP Raj sir, A. Prakash sir, C. Vivek Kumar, G. Sweta madam, K. Hemalata madam, and also who helped me directly or indirectly in successful completion of this FDP. Last but not the least, I thank all the participants of various engineering colleges for attending this FDP. Thank you one and all. Thank you. Jai Hind. Dear participants, we are sharing the feedback link in chat box and at the same time in WhatsApp group. Please complete the feedback. This feedback consists of all the 5-day sessions feedback. Please complete, and after completion of the feedback, you will get the certificate. Thank you, one and all. Thank you.
Thank you, sir.
Gangaram, sir.
Okay. Okay.
Thank you
sir.
very much, sir.
Okay, sir.
Hemalata, madam. Hemalata, madam. Please post the link in chat box and keep the meeting for 5 minutes. Okay.
Okay, sir.
After 5 minutes, we can end the meeting, madam.
Okay, sir.
Dear participants, already we have kept the link in the chat box. Please fill it, the feedback form, and get the certificate. So the same link will be posted in WhatsApp group also. If anybody missed it here, please go to WhatsApp group and complete the feedback and get the certificate. Thank you, one and all. Thank you very much.